Okay, so today I'm going to be making a 3D printable dog or cat bowl in Rhinoceros 3D. I want to include a custom name etched on the side, so if anybody wants to print their pet a new custom food or water bowl, all they have to do is follow this tutorial and they'll have the files they need to print one. I'm going to start by drawing half a cross section, so let's maximize our front view here. I want to make this bowl about 6 inches wide and 2 inches tall. I've got my graph plane set up in inches with 1/4 inch subunits. Let's start with a control point curve. So come up here and click control point curve. Start at the origin, and then I'd say about 2 inches over, make another point, and then another point. Then come up about 1/2 inch over and 1/4 inch up. Then about here, and then I'm going to make 3 points in a row here, and then I'm going to bring it up to the top about 2 inches up. So let's press enter. So this is going to be the outer wall of my cross section. What I'm going to do next is offset this curve to my thickness. So come over here to curve, click offset, offset curve. All right, so now it wants to know up here, side to offset, this side, and we got to make sure the distance is what we want. I think 0.1 is what we want, and it's already set to that, but just to show you how to set it, all you have to do is type 0.1 and press enter. That sets this setting right here, and then you click which side of the line you want to offset. That creates two sides of this bowl, both sides, the inner surface and the outer surface. I'm going to round this right here, and the easiest way to do that is to create a diameter circle. So hold down your circle menu button and then come over here and click circle, a diameter circle, and then making sure that your O-snap is enabled and your end feature of O-snap is enabled. Draw your diameter circle from end to end, like that. And now, to get rid of that inner circle, select both of these lines, both the inner and outer wall of your cross section. Come over here and press trim, and then trim that half of the circle, and press enter. So, we now have a cross section of our bowl. If I were to use this cross section to create a bowl, it would come off looking great, but there's one problem. If I were to make a bowl from this cross section, I could not 3D print it. And the reason is this right here. This overhang right here is a problem. You have to remember that when you're creating a 3D printed part, a 3D printer cannot print plastic onto thin air. And this overhang right here would present a problem if I were to try and have a 3D printer make this object. So I am going to reduce this overhang right here. And I like to reduce my overhangs and limit them to about 45 degrees. I know a lot of printers can go steeper than that, but I have always had success and have never really found it that significant a limiting factor to reduce my overhangs to about 45 degrees in a particular direction. This is the bottom, and I want to make sure that this, the steepness of this outer curve here, not the inner curve, but the outer curve, does not exceed 45 degrees. So how do I do that? I'm going to start by coming up here to Polyline, and I'm going to create a polyline that is at a 45 degree angle. And that's really simple to do. All you have to do is take one of these inch boxes and draw a line from corner to corner. That line is at 45 degrees. And then making sure that your come up here to move, and then select the end of this line. What we want to do is to combine it with the tangent of this line, but it's not snapping. And the reason is, if we come down to our O-snap menu, we have to click tangent object snap. Now when we bring our cursor over, it snaps directly to the tangent of this curve. And that's exactly what we want. I'm going to click. Now we need to bring this line over and trim at this intersection here. How I'm going to do this is select this line here, and then I'm going to trim all of this away. I don't need it. I'm going to click Trim here, trim, and just completely get rid of that line. And then I'm going to draw a new polyline by clicking here. I'm going to start at the origin and bring it over and past here so that these two lines intersect. Now I can trim them so that they join. I'm going to come over here and press Trim. I'm going to click here and click here. Now what I've done to my cross section is I have, if I were to revolve this cross section into a 3D object, it would now be 3D printable because this overhang no longer exceeds 45 degrees. Let's turn this cross section into a solid line. Right now it's not a solid line, it's in segments. You can select individual segments. Let's turn it into a solid line by coming over here and pressing Join. Now we have one solid cross section. Something that I forgot to mention is that when you are drawing the control points for this outer line here, these control points, you'll remember, make sure that this segment of the bowl right here is perfectly vertical. And the reason is you're going to be etching letters into the side of the bowl, and keeping it vertical makes that process simple. Okay, the next step is to revolve this cross section. We're going to do that by exiting the front view and then making sure our perspective view is easily visible. And then we're going to select our line, come up to Surface, and come down to Revolve. And the first thing it's going to want you to do when revolving a polyline is to define the axis of rotation. So that's pretty easy to do. Making sure that the end option is enabled in your OSnap, just select the two ends of this line right here. End, end. The next step is it wants you to define the starting angle of the rotation. By default, it should be 0. Mine is 0 by default here. But if yours is not 0 by default, all you have to do is press 0 and then enter. Now it wants you to define the revolution angle, is what it calls it. In other words, how much of a revolution do you want? We want a full revolution since we're making a bowl, not 3/4 of a bowl or half a bowl, but a full bowl. So we are going to define our revolution angle as 360 degrees, and we do that by punching in 360 and then enter. We now have our bowl in 3D space. So that you can better see it, I am going to come up here and press Shade Viewport, making sure that my perspective viewport is selected. I'm going to click this button here, Shaded Viewport. Now you can clearly see the bowl we have just made. The next step is to create our letters that we are going to etch into the side of this bowl here. We do that by coming up to the Solid menu and pressing Text. In this menu, you can select a particular font and the height. This is important, the height of the letters. I'm going to cancel out of this and explain to you why height is important. This flat section of the bowl, this flat area, is 1 inch tall. You can tell by the graph that's a little under 1 inch tall. So we need to make sure that we confine our letters in this flat area and don't go any further below this point right here. So since it's 1 inch, to give us some space, I am going to make my letters about 3/4 of an inch tall. So come over to Solid, Text, and then set the height to 0.75, 3/4 of an inch tall. For the name, I have Charlie the Pooch already set up here, so I think I'm going to keep that. Let's see, for a font, I'm going to do Comic Sans. No particular reason, I just have to choose off the cuff, so I'm going to go with that. And now, as you can see, it has created our texts in physical form. So let's place them really anywhere next to our bowl. And if you come up here to the perspective, you can see our letters floating in space next to our bowl. The next step is going to be to bend them around the outside of the bowl and then subtract them from the surface of the bowl and etch them into the surface of the bowl, in other words. So in order to bend these letters around our bowl, we're going to need two pieces of information. We're going to need to know the outside diameter of this bowl. I happen to know that it is exactly 6 inches, since that's how I drew the cross section, exactly 3 inches from the middle. 3 times 2 is 6. So let us draw a circle that is exactly 6 inches in diameter. Next bit of information we need to know is the exact length of these letters. And this is a little bit tricky because you need to capture the furthest point of the right side of the H here, and then the furthest point on the left side of the C here, and determine what that length is, and draw a line that represents that length. So I'm going to come over here to Polyline, and I'm going to switch to the top view. And what I'm going to do is I'm going to draw lines that come out from those points, the furthest point on both the C over here and the H over here. So I like to use the Quadrant object snap feature of OSnap for this. So let's select that. And I think I'll unselect end because I don't want to and tangent because I don't want to accidentally select anywhere else. And if you come here, Quadrant will grab that exact point, the furthest point right on to the right of the H. So let's grab that point, and making sure our ortho is enabled, let's bring a line out here to about this far, about 3/4 away from the origin. And then over here, let's do the exact same thing, and using our quadrant feature, draw a line all the way about 3/4 away from the origin plane. So now what we've drawn here are two lines that represent the entire length of these words here. And now what we need is a line that is an accurate length between these 2 points. And to do that is quite simple. You draw a polyline up here. Make sure your end feature is enabled in OSnap. And also intersection object snap is enabled. And then from the end of this line, come over until for this part I am not going to use end. I'm going to make sure that I use intersection or apparent intersection and click. Now, if I exit my top perspective and enter my universal perspective, I can see that this line here that I just drew perfectly represents the total length of these letters. So I now have the two pieces of information I need to start the bend. I'm going to delete these lines since I no longer need them. And then I'm going to bring this line over, and I am going to move the end of this line, and then I'm going to, with my quadrant re-enabled, just to be clear, what quadrant does is allows you to snap to 4 locations on this circle where it is parallel with the X and Y plane. You see how that works? It won't let me snap anywhere except here, here, and here. That is what quadrant does. Now I'm going to bring it down here. This is where I want to connect it. And now what I need to do is determine the length of this line. I know this length of the line. I know the length of this line matches these letters over here, but I do not know exactly what that length is. In order to figure that out, you select it, and then you come up here to Analyze, and then click Length, and then right here it tells you exactly its length, 8.15 inches. So we need, in order to bend these, we need to create an arc here that is exactly the same length as this line, but along this circle rather than straight. So I'll explain why this is important in a second, but for now let's create that arc by coming over here to Arc, click it, and then we need to create the origin of our arc in the exact center of the circle, which is this point right here. It just happens to be aligned with the graph, but if it wasn't aligned with the graph, you can come down here to O snap and click center, and that will allow you to snap to the center of any circle. If I come up next to the circle wall here, it snaps directly to the center of the circle. It's a very useful feature. Now, what we're doing here, to be clear, is defining the radius of the arc I'm about to create. And the radius always comes from the center of a circle out to the side here. That is our radius, exactly 3 inches long. Now, the arc feature in this program is very useful because it has this ability to, instead of defining the angle, 90 degrees, 180 degrees, you can instead give it an exact length. So let's click this length feature here and type in the exact length of this line here, which was 8.150 inches long, and press enter. Now you can't see the arc because this circle is blocking it, but I don't need this circle anymore, so I'll get rid of it. There is our arc. This arced line and this straight line are exactly the same length. Why I need these two lines is very important to the bend feature in this program. I am going to maximize perspective real quickly so you can see this better. What these represent, these two lines, are where the spine of the bend is going to start and where the spine of the bend is going to end. I'm going to use these lines to perfectly define my bend and ensure that when I bend these letters, they will perfectly wrap around the outside surface of this bowl. So let us do that. Let me demonstrate the bend feature by exiting the perspective window and coming to the top window. And what I'm going to do is grab the furthest to the left point by using my quad feature. I'm going to come up here to transform, move, and then select this corner here. And I got to be careful. I do not want end and I do not want intercept or center for that matter. I'm just going to leave quad enable, quadrant. I'm going to select the quadrant of this letter, which I happen to know I'm going to select the quadrant of this letter, which I happen to know is the furthest point to the left of this entire string of letters. Click, and I'm going to move it to this intersection of the two lines I drew. And now, before I bend it, I have to consider something. How far do I want these letters to etch into this bowl? What is the depth of the etch? It's got to be very, very shallow because you do not want to create a perfectly flat overhang that a 3D printer can't manage. I'll explain what I mean by that in a second. Let's see, I'm going to go with a value that is really small, that will show up but will not create a problem for our 3D printer. I'm going to get rid of grid snap and I'm going to enable ortho snap. And let's see, probably about 0.015, I'd say. So instead of trying to click on 0.015, I'm going to type in 0.015 and press enter. Now, with ortho enabled, I will essentially move these letters back 0.015. They should be 0.015 inches in from this line here where it started. So I'm going to move back to 3D space and show you what that means from this perspective so you may understand better. You'll notice that I moved from the sides of these letters, I moved them in this little amount here, which is 0.015 inward. All right, now I'm going to go back to top and we're going to commence the bend. I'm going to select the letters and not the lines, just the letters only. And then I'm going to come up here to transform, bend, and I'm going to, what it wants to know first is the start of the spine. And it wants, in particular, the start of the initial spine, the spine when it's straight. So that'll be right here where these two lines intersect. And let us enable intersect. I think it did it automatically, but let's just make sure it's enabled. Either end or intersect will work for this. Click. And now it wants to know the end of the spine, the initial spine. And that'll be the far end of this straight line here, right there. Click. And now disable ortho, and you will notice that it's starting to bend. From the top, the letters are starting to bend. Now to know exactly, now you can see why I drew this curve here. It allows me to just come up here and making sure that my end feature is enabled in OSNAP. I can click the end right there, and I have successfully bent my letters. If I go back to perspective view, there you go. There are my letters. They're perfectly bent, and the curve will perfectly match the wall of this bowl here. And all I have to do to move them in place is to move from, make sure center is enabled, the center of this curve here, the radius from the beginning of the radius of this curve here to the center of the bowl. And I'm going to do that, and instead of clicking it from here, well, I guess I can't click it here. That's the exact center of the bowl right there. Now I've got to move them up, so I'm going to exit perspective, and from the side view I'm going to move them up. I'm going to leave grid snap off, and I'm going to turn on ortho. I'm going to move them up until they sit right about where I want, right in the middle of this flat area. And there you go. We have now placed the letters on the side of the bowl, and they are ready to be etched out of the bowl. Etching or differencing these letters into this bowl is very simple. Something I want you to pay attention to is notice how these letters are sticking into the bowl a slight distance. In fact, they are sticking into that bowl exactly 0.015 inches. So, in order to difference them, all I have to do is select my solid, the solid I want to keep, and come up here to solid and press difference. I do want to delete my input. You'll see what that means in a second. My input that I will be deleting will be the solids that I'm using to difference from my bowl, which will be each of these letters. So let's select them one by one. It wants you to select surfaces or poly surfaces to subtract with. And what it means by that is these letters. Here we go. Oop, make sure I dot my I's. Once you have your input selected, press enter. And there you go. The letters are now etched into the side of the bowl. This bowl is done. It's got its custom name etched into the side. You can see from the bottom that it has this 45-degree slant, and there is no steep overhang at the base here. It'll sit flat on any surface. It is perfectly 3D printable. If anyone wants to create their own bowl with their own custom name, I hope this tutorial was helpful. Thank you for watching, and I will see you next time.